E equals mc squared. Though relativity asserts Earth gravity as the manipulating force for mass increase due to acceleration, it lacks the performance to the lack of mass itself in spacefield space travel. Quanta physics perspective shows that there is a subtraction element to E equals mc squared in space maneuvering while in space. The two elements involve the first Earth gravitation but also a subtraction clause to low-density fields, zero-point energy fields. Gravity, which is explained as manipulating energy, the moving mass doesn't explain a moving mass in the lack of gravity. The single E equals mc squared equation do not explain the full scenario. Big G, little g equations. The big G is based on the same suffix as the little g equation where in fact they don't. They are opposite scientific equivalence equations. It is this analogy that optimizes relativity into an unfinished work, as it is the hope that quanta physics theory perspective will join theoretical physics into better standard physics theory. While Albert Einstein is famously known for the mass-energy equivalence formula E equals mc squared, the concept of mass itself predates him. Isaac Newton, in his Principia, defined mass as the quantity of matter arising from density and bulk, distinguishing it from weight. Furthermore, the idea of mass-energy equivalence, though not in the exact form of E equals mc squared, was explored by others before Einstein, including Henri Poincaré and Olinto de Pretto. Here's a more detailed look. Newton's contribution. In 1686, Newton defined mass in his Principia as the measure of matter based on its density and bulk, and he clearly differentiated it from weight. Early explorations of mass-energy equivalence. Olinto de Pretto. In 1904, de Pretto published a paper suggesting that the potential energy of a moving particle could be expressed as mv squared, linking it to the mass of a particle vibrating at the speed of light. Henri Poincaré in 1900 also discussed the relationship between energy and mass, particularly in the context of electromagnetic phenomena, though not in the same concise E equals mc squared form. Friedrich Hasenorel. In 1904, Hasenorel derived an equation E equals 3/8 mc squared relating energy and mass, though his work is noted for some differences and potential oversights compared to Einstein's. Einstein's breakthrough. While others explored the relationship between mass and energy, Einstein's 1905 paper on special relativity provided a more complete and accurate understanding of the mass-energy equivalence, culminating in the famous E equals mc squared. He also demonstrated how this relationship is connected to the conservation of momentum and the behavior of systems emitting radiation. In essence, while Einstein's E equals mc squared is a cornerstone of modern physics, the concept of mass, and the early explorations of its relationship with energy, were developed by earlier scientists like Newton, Poincaré, and others, according to physics journals and physics forums.